Well, welcome back. So this is experiment 2, and the idea of this is to test a different form of drilling. You might be able to notice here nodule ST13, so this is sandstone 13. This is the hole that I made previously using the wooden drill and the sand. That was 2 hours and 20 minutes. This is the other side of the hole. But what I've done now is I've prepared everything for drilling with what we call a hollow drill. There's clear evidence of hollow drills being used in the Neolithic and obviously in the Bronze Age in the form of drill cores or bore cores, they're called sometimes. And what those cores demonstrate clearly is that something tubular is being used to drill parallel holes through stone. Now, in this case, I'm using a length of copper mounted onto a hazel drill, just driven in there. I've sharpened the hazel and driven it into the pipe. And just in case you're wondering, and you're sort of saying things like, oh, well, they wouldn't have had copper pipe. Well, clearly this is the earliest metal that humans have discovered, and we have clear evidence of them shaping it and flattening it into other things. So I've kind of taken that evidence as an example that they could have easily created a tube, a flattened sheet that's just rolled around a stick, for example. So this is my starting point. The sandstone is Mohs hardness 5, somewhere around there. So it's softer, for example, than granite, which would be 6 to 7. It's softer than things like sarsen, which is a sort of very quartz, glued sandstone, which is, again, hardness 6 to 7. So although this is softer, there are still many Neolithic artifacts made from sandstone with holes drilled through them. So it's also acts as a good datum, a good baseline for this experiment. I have the exact timings for this hole using the drill in the sand, and I've got, hopefully, we'll have equivalent or comparable timings for this hole. You're probably wondering what this strange contraption is. And the problem with a tube drill is making inroads into the stone initially. So without some sort of existing disc that the tube can sit into, it's just going to skid around the surface. So what I've done is I've drilled a hole through antler, which would be easily achieved. I'll do that as another experiment, but obviously if I can drill through stone with a wooden drill and sand, then I would easily be able to drill through antler with stone and a wooden drill. So I've drilled a hole basically as a locator for my tube drill. It will stop it initially, till we're into the stone, from just moving around and skidding off that surface. So the hole there, I've used the tines of the antler as a kind of clamp, as a vice. So the nodule is held within there and tied in so that it can't move too much. I've got random bits of antler just holding it onto my previously used bag of sand, which basically creates a clamp or a vice. So hopefully I won't lose too much energy and effort in starting the hole. That's the key. So the principles remain the same. Although I'm using a tubular drill, I've got my faithful hazel bow, I've got a supply of water, I've got sand, and I've got my boxwood pivot. So the plan goes that I fill the hole with sand, add some water as lubrication to break a bit of that friction, place my drill into my bow, place the drill into the hole, on goes the socket, and let's see if this is stable enough to actually operate. I'm just bringing the string of the bow further up so that it doesn't glide on the copper. I'm not applying massive amounts of pressure. I'm just letting, hopefully smoothly, the copper run the sand into the sandstone. It's obviously a little bit tricky to keep it upright. Hopefully we'll settle into some sort of, there we go, settle into some sort of rhythm. That would be ideal. Just going to increase, let's get a sludge going in there. A bit like the previous experiment, if you spent an inordinate amount of time watching it, you'll have seen that the process refined dramatically as I went on. Let's hope it's the same with this. These are early days. I'm obviously going to time everything. I am timing everything just to see how long this takes in comparison to the other methods. What I've done as well is I've measured the length of the copper tube as my datum. So as this continues to wear, I can check how much the drill is wearing compared to the stone. So I'm getting into a rhythm really. It's going to be interesting when this is finished. It's just going to take a while to build up a bit of a sort of sandy paste, an abrasive paste in there. But it'll be interesting again to see what shape this hole is. If you watched the previous experiment, you'll know that the hole was tapering quite dramatically, and it would have taken a lot longer than the video you watched to make that hole parallel. I'm hoping that although the core of this method will be tapering, the hole itself will be quite parallel. Only time will tell. The first thing really is just to refine this bowing, make sure it's running efficiently, and get it cutting in there. Oops. I think what I'll do as well as I go is I will do sort of sections on camera and sections off camera, otherwise you're going to be watching for quite some time. Let's just take that out, something strange has happened there. And let's just have a look, try and rejiggle it. So the whole thing has come loose, that's quite annoying. That is quite annoying. Let's get that bedded in there. Drill in. Try and get that in that hole. The key to this is making sure that it goes back in the same place, of course. Otherwise we're just making extra work for ourselves. Oh, okay, so my bow has lost all tension, so I'm just going to have to sort that out before we go any further. Not sure what's going on there. Let me have a look. I'll come back to you. Okay, so I've just reorganised the bow. The knot came undone, so I was sort of flapping in the wind really. And just going to stick my drill back in there. Added a bit more water. This is always the hardest bit of this process, is the starting, I suppose. Trying to keep everything in order. Okay, let's get a rhythm going. You can see the stone is moving. It's not ideal. No, it's not ideal. Stop there. So you could see everything was moving around way too much. The antler clamp, the drill support, I suppose we would call it, was sort of moving suddenly. So I've taken it all off, and this is what we've got so far, which is, I think, quite surprising. We've got a 2mm circular groove in our sandstone. I don't think that took long. I mean, obviously you've just been watching, but I want to say sort of 5-6 minutes of actual drill time, maybe more. I'll check. And what's also interesting is that the copper drills, so that's 2mm in the stone, 2mm in the stone, and the copper drill has no visible wear, so there's no reduction in length of the 120mm starting point. So there must be wear, obviously, because there's sand moving around that copper, but it's negligible at this stage. So I've just taken a bit of time to reconfigure my clamp. Trying the tubular drill by itself just wasn't stable enough. I'm hoping I've also secured the copper into the hazel slightly better. And we'll try again. So I'm just going to try and get everything but large lumps of sand into that hole. I feel it with my fingertips. I don't know why the sieving didn't work this time, strangely. Must have been a bit careless. What's good is that we've got a groove in the stone, so hopefully after not too much of this drilling, if this all holds together, hopefully we'll get a bit deeper into the stone and that will help. So in goes our drill into the hole, socket on top. Let's see if this is going to work. Just need it to start. A bit wibbly there for some reason. Just get a bit of movement. Feels like it needs way more water. It's obviously all dried out in the meantime. Maybe a bit more sand. Still requires that slurry that we got from the first video to really make it work efficiently. Let's see. Oh, things like that are very annoying. I'm trying to be too aggressive. You can see this whole thing's moving. The setup's not ideal. I'm going to stop that again. It's only going to work if we get this right. So, we're back again. This is, to be honest, the point of these videos is to show you the process. If I just rocked up and gave you a perfect hole through a piece of stone and said I did it with a copper drill, well, that's not really teaching us anything, is it? So I think, although it's reasonably frustrating, it's quite good to see me struggling to achieve something that I'm sure is achievable. I'm trying to make sure the string is maintained down on the drill. There's a lot of noise at the moment. Let's just keep that going. Obviously, you can hear the waste friction, the excess friction. There's too much of it everywhere, actually. It's still pretty loose in there. Not sure this is working. I think what I'm going to do is take this off, clean it up, we'll have another look, see where we get to. Okay, I've washed this all off and just wanted to show you the error of my ways, really. You can see what started as quite a nice circular core has become this catastrophe of various grooves and marks, and that just tells me essentially that I'm doing something wrong. At the moment, I think what seems to be going obviously wrong is that the clamp, the antler drilled through to hold the hollow drill in the stone is just not secure enough. So because this is moving, we're getting an irregular drill through the stone. So I'm going to leave this here as a experiment that's learnt lessons, and I'm going to follow this up with another video where hopefully I get things more right. I know what I have to achieve. I have to achieve a secure location for the hollow drill on the stone surface. That's what I have to achieve. So the next video hopefully will show that that's possible. But thanks for watching, and again, as I've said already, the point of experimenting is that 90% of experiments fail. That's the point of this whole process. They fail and we learn from that failure. If we did everything perfectly the first time, we wouldn't learn much. So there we go. I'll try again. Thanks for watching.